Today we will solve different numerical problems based on Venturimeter. So read the first problem. A horizontal Venturimeter is provided in a pipe 300 mm dia. So pipe dia, that means one section. So here this is D1 equal to 300 mm. So this is 0.3 meter, and conveying water. Reminded the liquid is water. The throat dia 150 mm. That means this is 2 section, we know that, and this is 150 mm. That is 0.15 meter. If the pressure in the pipe 160 kPa, kilopascal, that means here this is pressure intensity. This is 160 kPa. That means 160 into 10 to the power 3 Pascal. Pascal means Newton per meter square. And the vacuum pressure at the throat. Throat means 2. And vacuum, so it will be negative. 350 millimeter, that means here this is actually pressure head. And this is 350 millimeter, and so here this is 0.35 meter, and due to vacuum it will be negative. Millimeter of mercury, but we have to convert it into head of water. So multiply 13.6 specific gravity of mercury, and this will be meter of water. Now we have to calculate Venturi head. This is H, and we know that this is P1 by omega minus P2 by omega. So here P1 160 into 10 to the power 3 by omega, specific weight of water, this is 9810, and minus P2 by omega here, this value is this, and minus this is plus 0.35 into 13.6. And you calculate this figure, and this will be 21.07. This is meter of water. Now we have to calculate actual discharge. And we know that actual discharge, this is Q equal to CD. This is coefficient of discharge into A1 A2 by root A1 square minus A2 square into root 2GH. Now we have to calculate A1 A2, that means area of pipe section and area of throat section. This is A1 pi by 4 D1 square, and so here pi by 4 D1 is 0.3. This meter square, and A2 here, this is pi by 4 D2 square, so this is pi by 4 0.15 square. And if you put the value here, coefficient of discharge here 0.98, so here 0.98 into the value of A1. If you put this value A1 into A2 by root A1 square minus A2 square into root 2GH, the Venturi head here, this, and this value will be here 0.364 meter cube, and this is answer here. Yeah, this is answer. Now read the second problem. Read the second problem. A 300 millimeter into 150 millimeter inclined Venturimeter here. Yeah, remind it. This is inclined Venturimeter. Is installed in a 300 millimeter dia pipe. That means here D1 equal to 300 millimeter. That means 0.3 meter. The water is at 30 degree to the horizontal. Remind it, this is theta, 30 degree. Yeah. The water is at 30 degree to the horizontal. The throat section being 1 meter from the entrance. That means here AB. Yeah. The distance between entrance and throat section, this is 1 meter. Yeah. And the flow of oil, here the liquid is oil. Yeah. Being up the meter. Pressure gauges at entrance and throat show reading this kPa. So here this is pressure intensity. P1 equal to 150 kPa. That means 150 into 10 to the power 3 Newton per meter square at pipe section, and at throat section this is 75 kPa. That means 75 into 10 to the power 3, this is Newton per meter square. Yeah. So first of all we have to calculate Venturi head, and for inclined Venturimeter we know that this H equal to P1 by omega minus P2 by omega and minus AB sine theta. Yeah. So here P1, this is 150 into 10 to the power 3, and omega is specific weight of oil, and this is 9810 into S for specific gravity of oil, and here the value 0.80. Yeah. This is P1 by omega minus P2 by omega. Here P2 75 into 10 to the power 3, and similarly omega 9810 into 0.80. Yeah. And minus AB. Here AB 1, and sine theta, this is sine 30 degree. Yeah. And this value will be 9.057 meter of oil here. Yeah. Now we have to calculate actual discharge. Look at the board. Actual discharge Q, this is equal to coefficient of discharge A1 A2 by A1 square minus A2 square into root 2GH. Yeah. Similarly, we have to calculate area A1. This is pi by 4 D1 square, and A2, this is pi by 4 D2 square. Yeah. And putting this value, and this answer will be 0.237. This is meter cube, and this will be the answer. Yeah. And for simplification of calculation, you can write the actual discharge in this form. Look at the board. Concentrate. Q equal to CD into A1 A2 will be converted in this form here. This is CD A1 root K square minus 1 into root 2GH. Yeah. Here K equal to A1 by A2. That means pi by 4 D1 square by pi by 4 D2 square. pi by 4 cancel. That means here this is d1 by d2 whole square. Yeah, and we know that pipe dia will be twice the throat dia. That means here the value will be 4. Yeah, and here the value 300 by 150. That means this is 4. Yeah, and here k square, that means 4 square, 16 minus 1. That means k square minus 1 will be root 15 always time. Yeah, that means this equation will be in this form, k square 4 square minus 1. That means root 15 at all the time, and this is root 2gh. That means you can avoid root a1 minus a1 square minus a2 square in the simplification from root 15. Yeah, so and this answer will be this. Yeah, the first portion here. And the second portion, instead of the pressure gauges, the entrance and the throat section of the meter are connected to a differential manometer. That means here differential manometer will be connected instead of pressure gauges. Yeah, then find the reading of manometer. That means deflection here. Yeah, so look at the board. Here we know that H equal to Y into S minus 1, and here the Venturi head 9.057 and Y, and S means here SM by SO because this is oil minus 1. Yeah, and here Y, SM means 0.6, and specific gravity of oil, this is 0.80 minus 1. And so here the value Y will be 0.555 meter. That means this millimeter. Yeah, and this will be the answer of the second part. Yeah, and we will solve again another one problem based on Venturimeter on the next day. Yeah, so thank you.